Astronomers have discovered the closest black hole to Earth. What is the biggest thing in the solar system? Well, you probably would say the sun, won't you? But if I told you there is something 10 times more massive than the sun and is also believed to be Earth's cosmic backyard, I'll end your curiosity by letting you know that scientists have discovered Gaia BH1, the black hole thought to be the nearest to Earth. Black holes are perhaps no stranger to science fiction and science facts. They have been the subject of many science fiction thrillers, including the 2014 movie Interstellar, and they are often portrayed as dangerous monsters that consume everything around them. Luckily, they are out there and far away. But this black hole is unique because it has been so close to us, and yet we have not been able to detect it for a long time. You might not know this, but black holes are the leftovers of stars that died long ago, which is quite cool, right? Another amazing fact about these mysterious black holes is that their gravitational attraction draws surrounding gas into itself. If the hole is surrounded by gas or is closer to another star, extremely high temperatures are reached due to the object's entry into the hole. This burning hot gas emits light that can be detected, acting as a torch that can be easily seen throughout interstellar space with the appropriate scientific equipment. Feeding black holes, as they are referred to, are among the brightest objects in the universe. But on what do they feed? Do they prefer eating people, bugs, or aliens? To put your mind at ease, they do not consume food in the same way that humans do. They are usually interested in feeding on the matter. Scientists are unable to detect them because they do not give off any light, as their name suggests black. Isn't it true that sometimes the questions themselves contain the answers? According to the Times, these black holes give themselves away by emitting X-rays, as they do our neighboring matter, which helps scientists detect them. Proceeding on the discovery of Gaia BH1, it would be natural to assume that the above process would have helped in discovering Gaia BH1, but this black hole isn't like others. While the aforementioned methods were successful in locating most black holes, the dormant Gaia BH1 presented researchers with significant challenges. Keeping it simple and interesting, I will bring to your knowledge that dormant black holes don't produce X-rays, since they don't feed. Even though they are more common, these inactive black holes can be more difficult to detect. Now let's zoom into the troubles and scenes the scientists went through just to detect this black hole. According to the sources, Al-Badri and his team had searched for dormant black holes for the last 4 years, using a wide range of datasets and methods. Hats off to them. Significantly, their prior efforts, along with those of others, had all brought up a plethora of binary systems that were passing themselves off as black holes. But this time was the first time the search bore fruit. Al-Badri and his team originally identified the system as potentially hosting a black hole by analyzing data from the European Space Agency's Gaia spacecraft. Well, Gaia was able to record the minute abnormalities in the velocity of the star that were caused by the gravity of a large object that could not be seen. Al-Badri and his teams turned to the Gemini multi-object spectrograph instrument on Gemini North in order to conduct more in-depth investigation of the system. This instrument mirrored the velocity of the companion star as it orbited the black hole and provided a precise measurement of the orbital period of the companion star. The follow-up observations carried out by Gemini were essential in determining the orbital motion and consequently the masses of the two components that made up the binary system. This enabled the team to determine that the central body was a black hole that was approximately 10 times as massive as our sun. The team relied on Gemini North's exceptional observational capabilities and on Gemini's ability to produce data on a tight deadline, as they had very little time to complete their follow-up observations. Surprisingly, when the team got the first indications that the system contained a black hole, they only had 1 week before the two objects were at the closest separations in their orbits. Measurements at this point were essential to make accurate mass estimates in a binary system. Moreover, Gemini's ability to provide observations on a short time scale was critical to the project's success. The present modules that astronomers have developed to explain the evolution of binary systems are having a difficult time explaining how the unique configuration of the Gaia BH1 system might have come about. More specifically, the progenitor star that was eventually transformed into the recently discovered black hole could have been at least 20 times as massive as our own Sun. This indicates that it would have only existed for a few million years. But do you know what could have happened if these two stars would have been formed at the same time? To your knowledge, if these two stars would have formed at the same time, the more massive of the two would have rapidly expanded to the size of a supergiant, swallowing the other star in its expanding mass before the latter could mature into a true hydrogen-burning main sequence star like the Sun. Despite what the findings of the black hole bear, it is still unclear how the solar mass star could have survived the period and emerged as a seemingly normal star. All theoretical models that allow for survival anticipate that the solar mass star should have ended up in a considerably closer orbit than what is observed. This will require astronomers to revisit their theories of how binary stars, seems like the one containing Gaia BH1, grow and evolve. On the other hand, this also indicates significant gaps in our understanding of how black holes arise and evolve in binary systems. It also suggests the presence of a population of dormant black holes in binaries that have not yet been examined. And that is it for the day. Don't forget to hit the like and subscribe button. See you in the next video.